Continue with the manipulating the transfer function. We will use similar transfer function that we have derived, or we have established in the previous session. All right, so the first transfer function is G1, which is first order system, and the second transfer function is second order system. And we have seen how the plot looks like. But then, if we would like to know more about the response output in terms of values, where the values oscillate when the values is constant, converge to certain level, then we need to use these codes, right? So first we consider the managing the clear cursor, and then we set format such that the decimal point is not so long, and then since we are using the previous transfer function, we just make use G1 and G2. Okay, so how to extract each constant or each response output at this specified time? We can use this code, right? For G1, since we are using step input, we can also set to impulse, right? So impulse, and then this will be 0 and also 0. So now we have for impulse, we have for step, for each order, first order and second order, and then maybe we can add more for the second order. So second order is here is should be maybe 1, maintain as 1. So this one is the impulse. For the impulse response, maybe we need to change this to T2 and Y2. So everything looks good. Right. So we can run this and see what is going on. All right. So we can see that for impulse response, it starts with a spike here. This is for second order, of course, and similar goes with first order, a small spike, and then it almost approaching to exponential decay, and very stable. If we zoom at this section, is approaching to 0, but the constant of exponential decay is very small. That's why it is approaching to 0 very slow. So if we go back and then check on the second order, yeah, it is approaching to 0, but still oscillating. Maybe if we consider more time, it will approach to 0. So now let's consider the step input. So we can either change this figure to reflect the plot for step input, but we can also copy and put the figure 2 for the step response, where this reflects to Y1 and T1, and this one is T3 and Y3. So now we can see and observe both for step response and also impulse response for both first order and second order, right? So let's have a look on the second order and first order for step response. So we can see that the first order is approaching to 1 as the time approaches to 10, or it is stable from this region. So at t equals to 1, it is approaching to t approaching to 10 seconds, it is approaching to 1, which is the value that we want, because step response, in this case the input is 1. So it looks good. And then if we consider the second order, the response is fluctuating as it reach to 7 seconds. It is fluctuating close to 1, which is also a good sign of output response. This is a good and stable response, because it oscillates and gradually reduce the oscillation and approach to constant value, which is what we expect for the second order system. So this codes basically is modified to provide better illustration for the graph, such that we can see clearly in terms of line. So here is the code for specifying the line, the color of the line. So in this case we use blue and red. So red is R and blue is B, and the intensity of the line width is 2, and for X label we use an interpreter. In this case we are using latex, so that it provide or beautify the font that illustrate in X label. Similarly goes for Y label. And then we also use the latex interpreter to beautify the legend for the each of the line, to mark or to point the line of first order and second order. And the last one, this one is to set the scale. So what is meant by this is that the scale here, okay, so it is specifying the intensity or the font size for each value in this X and also Y axis.